And here we have the notes for section 1.6, the trigonometric functions. So radian measure, so the radian measure of an angle is the length of the arc that cuts, that the angle cuts from the circle. So you're talking about an angle, a radian angle, that occurs is whatever angle in there makes that edge around the edge of the circle the same length as a radius. All right, so here, for example 1, it says find the length of an arc summed in a circle of radius 3 by a central angle that measures 2 pi over 3. So this is going to be our formula. So we're going to do the circumference over 2 pi is equal to the length of the arc over the angle we're talking about. So all the way around the circle takes 2 pi radians. What piece matches with our angle? So we need to find the circumference of our circle. So that's 2 times pi times r. So our radius is 3, so it's going to be 6 pi. So this becomes 6 pi over 2 pi equals L over 2 pi over 3. And over here I'm going to reduce this fraction. That's actually 3 over 1. So now I can do cross products. So L times 1 is just L. Going the other way is 2 pi. So the length of that arc is 2 pi. Down here you have the definitions of the trig functions. So an angle measure theta is placed in standard position in the center of a circle radius r. The 6 basic trig functions are as follows. So what that means is if you have your angle placed at the origin, this distance is r, this distance is y, this distance across the bottom is x, and that is my theta. So sine is y over r, opposite over hypotenuse. So those rules, opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent still work. And these 3 over here are the reciprocals of those 3 over there. Here's just pictures of the 6 trig functions. So there's sine, cosine, and tangent, and then their reciprocals, the cosecant, the secant, and the cotangent. So when you're talking about trig functions, you can talk about periodicity. So that just means that the values repeat with a given period. So like for sine and cosine, the period is 2 pi. So it's right down here actually. Tangent and cotangent have a period of pi. So example 2 says show that cosine is an even function and sine is odd. So remember your rules to do that were you checked f of x, f of negative x, and negative f of x. If the top 2 are equal, that you had an even function. If the bottom 2 are equal, you had an odd function. So we'll do, we'll just pick 1 for example. So we'll do the cosine of 1, the cosine of negative 1, and the negative cosine of 1. And we'll see what values we get. Now you do need to be in radian mode in your calculator, so if you are not, you need to flip that. So the cosine of 1 is 0.54. Cosine of negative 1 is 0.54. So these two match, so this is even. I'll do the same thing with sine. Sine of 1, sine of negative 1, and the negative sine of 1. So the sine of 1 is 0.84. Sine of negative 1 is negative 0.84. And this last one is actually always the opposite of the first one, so it's also negative 0.84. So these two are equal, so odd. All right, so example 3, find all trig values of theta. If sine theta is equals to negative 3/5, there's a typo in your notes. You just have a negative sign there, potentially. And tangent theta less than 0. So what I'm going to do is I'm going to draw a right triangle. So sine is y over r, so I need to find that missing side. So a squared plus b squared equals c squared. So b squared is equal to 16, so b is 4, so this side is 4. So sine of theta is negative 3/5. So cosine of theta is going to be 4/5. And tangent theta is opposite, so 3/4, but negative. So then to do the other ones, the cosecant is the reciprocal of that, so negative 5/3. The secant is the reciprocal of that, so positive 5/4. And the cotangent is the reciprocal of that, so negative 4/3. Okay, transformations. So you have the basic equation of the graph, a sine bx minus c plus d. So a is the amplitude, the absolute value of a. This b value lets you find the period. You divide 2 pi by b. C shifts the graph horizontally. Sometimes this is called the phase shift. And then d is the vertical shift. Moves the graph up and down. All right, so for part A here, or for example 4, determine the A period, B domain, C range, and D draw the graph. So there I do need to do one little conversion first. If you notice, you got brackets and then parentheses. So I need to factor this 2 out. And when I do that, this becomes pi over 2 because I divided the 2 out. So now I have my values. So for this problem, A is equal to 3, B is equal to 2, C is equal to pi over 2, and D is equal to 1. So for part A, the period, that's going to be 2 pi over B, which is 2, so just pi. For part B, the domain, so sines and cosines, the domain is always all reals. C, the range. So to find the range, you actually take your vertical shift, in this case is 1, and you add and subtract your amplitude. So the range is going to be between, so you have 1 plus 3 and 1 minus 3. So that's 4 and negative 2. So negative 2 less than equal y less than equal 4. Then part D, we're asked you to graph. So this is a cosine function. So cosine has this generic shape, but it's going to get shifted right by pi over 2 units, and then shifted up by 1 unit. So this is kind of a sloppy curve, but you get the vague idea. Okay, musical notes are also produced by sinusoidals. So here you have a computer analyzes the pressure displacement versus time for the wave, blah, 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 estimate the frequency. So the trick for this is frequency is equal to 1 over the period. So if the period is equal to 2 pi over b, frequency is the reciprocal, or b over 2 pi. So for this problem, there's my b value. So the frequency is equal to 2488.6 divided by 2 pi. So 2488.6 divided by 2 pi. So that is, the frequency is 396 approximately, and the unit for frequency is hertz. Okay, and then on to the last page here, you have the inverse trig functions. So they undo, they return the opposite of the function. So given a value, what angle gave me that value? So a trig function takes an angle and outputs a value. The inverse takes a value and outputs the angle. So example 6 here says show that that's a 1-to-1 function. So the inverse sign for that section looks like that. So it passes the horizontal line test. And then graph the inverse would be something like that. So you get that nice little infinity looking loop. All right, so here are the rules for the inverse trig functions. There should be a little X right there. Not got blurry. There it goes. With the domains and the ranges. So example 7, find the measure of the inverse cosine of 0.5 in degrees and radians. So I'm actually going to start with degrees. That's actually just a calculator problem. So in radian, that's pi over 3 radians. To convert to degrees, you take your value and you multiply by 180 over pi. So in degrees, that is 60 degrees. Okay, so down here, so to solve, to move the trig function across, you use the inverse. So the inverse sine of 0.7. So this does not come out nicely. It is 0.78 radian, so no degree symbol. Over here, same thing. The tangent comes across. So x is the inverse tangent of -2, which is -1.11 radian. So whoops, off the bottom. So no degree sign. I believe that is the end of the section.